Guys, welcome back here to another video on EJT Tech. This is where we teach and learn electronics together. So in today's video, I'm going to be explaining this oscilloscope circuit that I just built on this breadboard. This circuit consists of what? An OLED display, Arduino Nano, and we have some kind of push button from some kind of little adjustment we'll be doing on the oscilloscope. So actually, we all know that as an electronics hobbyist, you need an oscilloscope to help you to enhance your learning in electronics, sort like reading some kind of signal that are generated by some circuits like sine wave signal, your pulse width modulation signal, which is something like your square wave signal, and we have your triangular wave signal. These are like general kind of signal that we have. There are all those signals that we used to call the sawtooth signal and the rest. So now, most of the time, these oscilloscope in the market are very expensive. So, and I thought of like building something that is simple so that you help like makers, electronics over here. So the first thing that I'll be doing is to explain the circuit explaining. So the first stage here, the circuit here is just a potential divider, that is voltage divider circuit. So it tends to take an input from here and it tends to limit the current again. That's going to the input of the Arduino, because the Arduino pin cannot handle much current. So in order not to fry up the pin of the Arduino. So now what we have here, you see that we have our input. Our input can either be a square wave, a triangular wave, or a sine wave, and all will be fed through this input with respect to what? With respect to ground. So that is just all about the input. Now let's talk about this push button circuit that is here. So you see that we have 4 push buttons which will be connected to D8, D9, D10, and what? D12. And we are going to be calling out the internal pull-ups, as in we are going to be calling out the internal pull-ups in the Arduino code or program. So now what we are going to be doing here again is that what? This is just a simple switching circuit. We tend to turn on this LED each time it receives a low here. That means a button is being what? Pressed. So it just tends to blink the LED to tell you that the button is pressed. So now this just majorly starts as a notification to know what you are doing. So now we have the OLED display here, which are going to display everything that is happening in the circuit. So now this display uses what we call the I2C communication bus to communicate to the Arduino, which we have it consists of 2 wires, which is the SDA and SCL. Then we have the power pin. So the SDA is the serial data and the SCL is the serial clock. So this is being fed to A4 and what? A5 of my Arduino. So this is what is happening here. So actually this is just what I have on the circuit, and I can see about the circuit. So I'm going to make more explanation during the demonstration of it. Okay guys, this is the Arduino code we are going to be using for this project. As you can see, it started by including some vital libraries, which are the wire library and the Adafruit GFS library, which is you have the OLED display. Then going down, we initialize the program and fall down back to the loop of the program, which include it's a functional program which includes the read wave function, data analyze, and so forth. If you need this code, just let us know down below in the comment section. Thank you. So we are going to be demonstrating the project at this point. So this is it, and this is my inputs. As you can see, this is my input. As you can see that it's responding to different kind of. This is my input of the oscilloscope. So now I'm going to be picking my circuits that I've built in a previous video on this channel, which is just a simple just a 555 timer, which is tend to generate a square wave output. So all pulse width modulation circuit. So that's what I'm going to be using. This is where I built the circuit. So I'm going to be powering the circuit for you to see what really is what's happening. See that the circuit is blinking. So this is our hello circuit, which is used with this 555 timer. So that's not what we are trying to do in this circuit. What we are trying to do in this circuit is for us to read this circuit. Now you make sure that the ground of this circuit is the same ground, and the ground of this circuit and that of the oscilloscope are common. So they are just common. So this is what I'm just trying to do here. Yes, as you can see. As we all know, you can see the pin 3. This is where the LED is. That is the output of the circuit. So we now know that this is the oscilloscope that is here. So now you can see that we have just reading some kind of signal from the output, because this is as my output now, my input. So you see that if I want to hold the oscilloscope, I press this button. You see that it holds the oscilloscope. So now, if I want to maybe this frequency that is here, this timing, You see that this is the maximum, this is up. If I go down, see that I can reduce it. You see it's more faster. So 200 microseconds is the minimum, so I can go up to down to 50 milliseconds, which is the maximum. And also if I want to select, this is select, so I can select whether up or down. I can select voltage difference. So the voltage difference, if I try to go down, see that I can go up to 10, 20, 50. So as you can see now, so let's connect it and see to the output. Let's look at the oscilloscope. You can see it's giving me a square wave output, of which I can be able to adjust the pulse width modulation. So let's adjust the pulse width and see. As you can see the pulse width, can you see the pulse width is, the width is what is modulated, it's increased. So as many as that, so I can do as many as possible. So this is just what I have for now. Yes, so I've shown you how the functions of this block work. So the circuit is very simple to build. Please, if you need an information about the circuit, you need more information about this project, maybe the code and the rest, and how to get the component, please leave a comment down below this YouTube channel. This video, give it a thumbs up. And also this project, I'm going to be making it on a ferro board, that means a permanent circuit for it, because it's something that I really need, because I'm going to be building a frequency generator in a later video, which I'll be using the same project to demonstrate how the frequency generator works. So see you guys, and I will catch you guys later. Thank you.